This is the Earth Science Classroom. Welcome back to the channel. This video is on Kepler. Now, Johannes Kepler was an amazing young scientist, thinker, and he thought outside the box. And with the addition of a gentleman called Tycho Brahe, he was able to add to what's called the scientific revolution and his thoughts on planetary motion. His three laws kind of govern how we understand planets and how they move around the sun. This is in the astronomy playlist, and this is part 1, looking at his first law. So Johannes Kepler was born in 1571 and died in 1630. He was a German scientist and student, and he was invited to come to Denmark, to a small island where a gentleman, a Danish noble and well-known scientist and astronomer called Tycho Brahe, was working in this observatory and had complete control on this scientific island, and he was in charge, and he was invited to go there as a student and be basically his assistant and work with Brahe on his observations that he'd been doing for about 2 decades. And Brahe had just observed various processes and movements within our solar system, and Kepler was there really to assist in the observations, and in particular he was given the chance to look at Mars and the orbit of Mars in more detail. So once Brahe passed away in 1601, he was actually kicked out of the island with the new king of Denmark. Didn't really like him, and he wasn't really the most friendliest of gentlemen, as literature suggests. Brahe was kicked out and died in Prague, and then was given all this information, all this data and knowledge was passed on to Kepler, and Kepler then used these observations to formulate his laws that govern planetary orbital motion. And these 3 laws are part of this video and underpin what's known as the scientific revolution, which was roughly 100 years of brand new revolutionary ideas coming out in between 1543 and 1640 that revolutionized how we think of our planet and our solar system. So Kepler's first law out of 3, the first one he made or formulated and published in 1609, was called the law of ellipses. Now, ellipse is a flattened or squashed circle, and previously understood through the geocentric model that was put forward by Ptolemy in ancient Greece over 2,000 years ago, was that the Earth was in the center of our known solar system and everything else revolves around it. Very rudimentary and just purely observational theory formed from these people, and it stuck for a very long time, for centuries, until Copernicus and his model put the Earth in the center, which really explained what's called retrograde motion, the movement or the apparent motion of Mars due to Earth, due to difference in speeds of revolution orbit. And this placement of the sun in the center kind of helped out to explain this process of Mars's motion, which the Greeks did notice but couldn't explain properly, especially with the Earth being the center of the universe. But the Catholic Church was very happy, so it stood for a long time. And then along came Copernicus, a Polish monk and scientist that kind of broke the mold and went out with this model, but only published it on his deathbed because of the fear of the Catholic Church, and that was in 1601. Now, the law of ellipses is saying that our planets revolve around our sun. The orbit is in the shape of an ellipse, not as a circle, because the geocentric model suggested that told everyone that the orbit was circles around the Earth, whereas we know now that it orbits the sun, and these orbits are elliptical, which is a flattened circle. So this is an ellipse. A perfect circle, if I just draw one right here as best I can, has a center, and the radius of a circle is the exact same length all around. It's the same radius. However, with an ellipse, as you see, that there is a shorter diameter and a longer diameter. So this is called the axes. And we have a minor axis, which is the shorter length. We have a major axis, which is our longer length, and I can just highlight these in different colors. the red axis being the minor, shorter one, and the green being the major axis, the longer one. So this is formed through the fact of two foci. So with a circle, there's one center, one single focus. However, with an ellipse, we have two focuses, and we call this foci as a plural. And these two are right there. Now, one of the foci has to be the sun in relation to our solar system. The sun is our center, and everything orbits around the sun due to gravity, but this won't be known until Newtonian physics is formulated through Isaac Newton. And this second focus is just an imaginary point in space that the orbit is going to move around. And because we have a major and minor axis, we have 2 points. This outside edge of our ellipse is the pathway of our planet's orbit or revolution. And let's just say this is Earth. And as Earth orbits around and rolls around the sun, it gets to a point where it's the furthest away on the orbit because of this shape, and this is called the aphelion. Now in Latin, a means away and helion means the sun. So away from the sun. On the opposite side, when the Earth is a closer distance or the closest distance to the sun, this is called the perihelion. Now the distance right here, this distance shown here, is our perihelion distance, and aphelion distance is right here. So you can clearly see there is a difference in distances due to the major and minor axis, and this is a obvious ellipse. And the measure, or to find out how elliptical this shape is, we would use a term called eccentricity, which is the measure of this using a scale from 0 to 1. 0 being more circular, 1 being very elliptical. And this is the first law that Kepler proposed in 1609, and it basically led him to formulate 2 other laws to have a comprehensive understanding of how planets move around our sun. This is the Earth Science Classroom. Thank you for watching. I hope you enjoyed the content. Check out more videos on our channel, and don't forget to subscribe. Thank you again.